Hello, class, receiving students and teachers. Thank you. Take your seats. Receiving students and teachers, we are going through another lesson, another revision lesson today, which is based on the strand Science in the Home, sub-strand Learning About Substances, and the outcome 8.3.2. All our questions or what we will go through in today's lesson is based on this outcome: identify and collect basic and acidic substances found in nature and use this data to elaborate on how this can be used to benefit the community. Receiving students and the model class, in today's lesson, you are going to watch a short video, and this short video has parts to it. The first part of the video, you will watch how litmus paper is made. Number 2, what is acidity? African violet, which will be used as an indicator. The pH numbers around us. And the last part, acid rain and morning glory blossoms. Morning glory is a name of a flower. Right? Those are the different parts of the video that you will be viewing. But before you view the video, I'd like to go through what is a pH scale. Receiving teachers, at the end of the lesson or in your own time, you may do a follow-up lesson on a pH scale. Class, I'd like you to get your books out, and I will give you a minute to copy the definition of what is a pH scale. Please copy that down. All right, I hope you all have finished copying the definition or what is a pH scale. It is a scale of numbers from 0 to 14, which shows how strong or weak an acid or an alkali is. The strongest acids have a pH of 0 or 1, and the strongest alkalis have a pH of 13 or 14. Now let's further look at the pH scale. Okay, from our definition, we said a pH scale of numbers. A pH scale is a scale of numbers from 0 to 14. And as you can see here on the monitor, we have numbers from 0 to 14. Okay. And this scale shows how strong or weak an acid or an alkali is. Now let's look at the different parts of the scale, the pH scale. This direction here shows acids. Acids have a pH scale from 6 to less than 7, which is from 6 to 0. Alkalis, the arrow here shows that this direction here, the arrow pointing to this direction here shows how strong or weak an alkaline is. From here, from 6 down to 0 shows how strong or weak an acid is. Is that clear? Right, what about the number in the middle? Which is, what is the middle number? Okay, 7 is the number that is in here, which is the middle number. Okay, the middle here shows neutral or solutions that are neither acid nor base. They are neutral solution. Give me an example of a neutral solution. Class, what is it? Water, right? Good. Now some more information. An acid has a pH value less than 7. The smaller the number, the stronger the acid. So 0 and 1 are numbers that show that the acid is very strong. If you have the acid, the pH value of 4 and 5, that acid is not very strong. Okay, it's slightly strong. But if you have a pH value of 0 and 1 or 1, that will show that the acid is very strong. Okay, what about alkalis? An alkali has a pH value greater than 7. The larger the number, the stronger the alkali. So if you have a pH value of an alkali that is 14, then you know that it is a strong alkali. Right? Next set of information on the pH scale. Pure water and neutral solutions have a pH value of exactly 7. So if you have a solution that has the pH value as a pH value of 7, you must know that that solution is a neutral solution. If you have a solution that has a pH value of 9, then you know that that is an alkali and it is slightly strong. Receiving teachers, a reminder again, please do a follow-up on a pH scale, on the pH scale, and provide information for your students to copy into their exercise book. For the model class, we will further look at this in our next lesson. Right, class, your activity for today, you will be watching a short video, and I'd like you to copy that instruction down. While viewing the video, you will write anything interesting that you have seen or learned in each part of the video. Right? So each part of the video, everybody should come up with something interesting to write about. All right, put your hands up if you have any questions on our activity for today. No questions? Receiving students and model class. We will now go on to watching the short video, and I expect every one of you to write something about each part of the video.
How to make litmus paper. These are litmus lichens. Litmus paper is made with them. The blue powder is taken from litmus lichens. When the blue powder is dissolved in water, it becomes an alkaline blue-purple aqueous solution. The value on a pH meter shows 9.46. After having a roll of paper observe the blue-purple aqueous solution, we will dry it. And we cut it into strips. Now blue litmus paper is ready. On the other end, in making red litmus paper, we will add this kind of acidic liquid into the blue-purple aqueous solution. The color is changed into red. The value on the pH meter shows 4.79. It is acidic. We will have a roll of paper absorb this red solution and dry it. Now red litmus paper is ready. Litmus paper that you use at school is made in this way.
What is acidity? Aqueous solutions. Solutions of substances dissolved in water have various kinds of properties. Aqueous solutions that share common characteristics such as having a sour taste are called acidic aqueous solutions. It is said that Robert Boyle, about 300 years ago, was the first to investigate acidic properties in detail.
I investigated its properties using milk. Some solutions clabber milk. This is caused by the acidic feature of the solution. If that is an acidic aqueous solution, it always clumpers milk no matter what you choose. Among the common characteristics, the most distinctive one is the change in the color of flowers. As for the flower, purple violets are suitable. First, grind the petals of the flowers and extract the juice. The color of the extracted juice is purple. Next, to make the change in color more apparent, use a piece of paper to absorb the juice. Now it's time to add an acidic aqueous solution. Just a few drops will do. The color will turn into bright red in a moment. As you have just seen, the substance that changes the color of violets from purple to red is an acidic aqueous solution.
The pH numbers of things around us. A pH is a kind of scale that represents a solution's properties and is indicated with numbers from 0 to 14. The base of a scale is pure water with nothing dissolved in it. Its pH is 7 and it is called neutral. And the solutions with pH numbers lower than 7 are called acidic. The smaller the pH number is, the stronger its acidity becomes. Some common things are listed here. Now let's check the pH of food with a sour taste: lemon, prickle plum, and grapefruit. We check the pH with a pH meter. First, we will check a grapefruit. The spot used in measuring is the rounded portion at the end of the device. We will measure it by placing a sufficient amount of juice there. Its pH is 3.2. A grapefruit is located here on the pH scale. In the same way, a lemon's pH is measured and its pH shows 2.1. And the pH of a very sour prickle plum is 1.9. The sourer the substance is, the stronger its acidity is. Contrary to acidic, the solutions with pH numbers larger than 7 are called alkaline. Baking soda and soap are two common examples. Now let's measure the pH of baking soda commonly used in the kitchen. When taking a measurement, we dissolve it in water, making an aqueous solution. Its pH is 8.2. In the case of an alkaline substance, the larger the pH number is, the stronger its alkalinity becomes.
Acid rain and morning glory blossoms. As rain dissolves carbon dioxide in the air, even under usual conditions, it shows a weak acidity of about pH 5.6. Rain that has a stronger acidity, then that is called acid rain. We have collected rainwater and measured its pH with a pH meter. Its pH is 3.8. It is strongly acidic. We collected strong acid rainwater and sprayed it on a morning glory blossom. "30 minutes later, when we wipe the water drops with tissue paper, the paper is tinted. The color from the flower petals have dissolved and bled out. Observing morning glory blossoms when it rains can help determine if it is acidic rain.
All right, I'll give you 1 more minute to just discuss with your group members and discuss what you have written in your paper or in your exercise book with your group members, and we will go through that together in class. right, let's have a look at what we have gone through. You were told to write anything interesting that you have seen or watched. And the video was in 6 parts: how litmus paper is made, what is acidity, African violet, the pH numbers around us, and the last one was acid rain and morning glory blossoms. Now you can give me your answer in any order. What have you discovered, or what interesting thing that you have seen? Let's go from one group to another. Or any volunteers in class. Receiving students, please tell your teacher. Anybody? You can discuss among yourselves again. Let's start with group number 9. Okay, group 9. Where is group 9? No need for you to explain in long sentences or think so what. Just give me a word that you know you have watched or heard. Come on, 80s. Livingstone. Ella, your group ready? All right, class, let's hear from Ella's group.
We have viewed a video and we've seen that they made blue litmus paper with litmus leeches and red with a acidic substance.
Right. Thank you. You all agree with what Ella has said? All right. Litmus paper is made from lichens. Okay. And you see a powdery substance being made. Then it's mixed with water, and that's how blue litmus paper is made. Whereas red litmus paper, it goes the same process, but there is an acidic substance that they use, add into another substance, which changes its color to red. And there, the paper is being dyed and made into a red litmus paper. Thank you, Ella. Most of you will have that. Any other things? Yawa, your group? Jean? Eddie? Lisa? Are you ready? All right, let's hear from that group. Thank you. Aquila's group.
Rainwater is a acid because it has a pH of 3.8.
All right, good. Okay, rainwater, it depends on the kinds of chemicals that are in the air. And In PNG, we do have factories, but not many, where the atmosphere is polluted. In other industrialized countries, the atmosphere is polluted, and when rain falls, the chemicals, when rain falls, rainwater is collected, and on the video that we have just watched, the rainwater was collected and measured, and its value was 3.8, which means the rainwater was acidic. And they used that to spray the morning glory blossom and found out that the color faded. That's the result of the work of the acid that has bleached the flower. And what will happen to the flower? Will it survive or it will die? All right, it will die because of its color bleeding out or fading. All right? So don't think that the rain that we receive is pure or it's good. In PNG, it may be okay, but in other countries that are industrialized, the rainwater may not be safe to drink. Right? Last one. You did not talk about the pH scale. The African violet. Thank you, Rachel.
African violet extract that's used to make litmus paper.
All right. The solution was used as an indicator. All right. And the litmus paper was added to that solution, or the solution was added onto the litmus paper, and you could see the change of color. Right, thank you for that, Rachel. Right, for the pH numbers around us, you have looked at some examples of fruits. Is that true? Yes. Okay. You shouldn't be finding it difficult to tell me something about the pH numbers. Okay, you should think about the fruits that they have tested, and not only fruits but other substances like soap and baking soda and the others that you have just watched. Right? Again, receiving teachers, this remaining time, you can use that to elaborate further on our lesson for today. It's only a revision lesson. Please cover the areas that are difficult for the students to understand. What is our key phrase for today's lesson, class? Okay, you are not wrong. pH scale. With that, thank you, class, for participating.